Hello, I'm Ron Mullison, Professor of Mechanical Engineering at Cal Poly in San Luis Obispo, and I have an experiment here which will verify the first law of thermodynamics by smashing a small piece of lead with two steel cylinders. I'll first describe the equipment, we will then run the experiment and collect some data. I have two steel cylinders which are suspended by nylon cords, allowing them to swing as pendulums. Initially, these cylinders will be held in an elevated position. Released from that position, they'll swing down and they'll strike a small piece of lead which has been folded over a thermocouple. This lead acts as a calorimeter and will record the rise in temperature as a result of the impact. We'll take a break now and we'll set up the cylinders and then return for the experiment. We're all set up now, ready to run the experiment. The two steel cylinders are held in this elevated position by a common line which wraps around two overhead pulleys. I'll cut the line on the center. The cylinders will be released simultaneously and will strike this piece of lead. The thermocouple is connected to a digital thermometer, and I've selected the record function which will allow us to have the maximum and minimum temperatures recorded. So let's go ahead and run the experiment. And let's go ahead and zero in on the piece of lead to see what it looks like after the impact. The lead has now been classically deformed, and we'll look at the temperatures. The max temperature is 79.0 degrees Fahrenheit, and the minimum temperature 70.6 degrees Fahrenheit. The loss in gravitational potential energy of the two cylinders in foot-pounds will be equated to the gain in internal energy of the lead calorimeter in BTUs. A ratio of these two energies will give us Joule's constant, and the number we're looking for is 778 foot-pounds per BTU. I'll be providing you with data for about 6 runs, and the data I will give you will be the mass of the steel cylinders, the mass of the lead calorimeter, the initial elevation of the cylinders, and the final elevation of these cylinders, also the initial and final temperatures of the lead calorimeter. For one of the runs, I'll be making about 6 thickness measurements for this lead calorimeter. Now, the thermocouple is located at one location within that lead calorimeter, and we would like to know if that one temperature reading is representative of the entire lead calorimeter. That is to say, we'd like to know if we have uniform temperature distribution within that piece of lead. One way of determining this uniform temperature distribution is to see if the lead has been uniformly deformed. And with calipers, I've made careful measurements at about 6 locations around that lead calorimeter, and I provide you with this data. And if the lead calorimeter has been uniformly deformed, then we can assume uniform internal heat generation and uniform temperature. With the data that I provide for you, you'll be computing Joule's constant, and you'll see how close you come to the published value, which is 778 foot-pounds per BTU. Thank you.